Hi, I'm Liz Maynard at Purdue University Department of Horticulture and Landscape Architecture. I invite you to join me in a review of the no-till pumpkin and winter squash work we did in 2020 at the Pinny Purdue Ag Center in Northwest Indiana. We know Indiana farmers are successfully producing pumpkins in no-till systems, and our goal is to develop and demonstrate workable systems at the research center so that we can conduct trials that lead to better understanding and improvement of the current practices. This project actually started last fall when we seeded the rye cover crop on October 2nd into a standing soybean crop. The soybeans were harvested just a few days later, and within a week some rye was up, and by April we had a nice rye stand, so we moved ahead with the project. We wanted to look at a couple different ways of terminating the rye for no-till planting pumpkins and winter squash. For comparison, we included a conventional treatment, or BARE, and in that treatment the rye was killed by tillage in April, and the soil was worked several times before planting. In the treatment that we'll be calling HERB, we killed the rye with glyphosate on May 21st, and then no-till planted into the residue. In the roll treatment, we killed the rye with a roller crimper, either just after seeding or just before transplanting. And then we had three crops. There was a jack-o'-lantern pumpkin variety, Bayhorse Gold, a mini Blue Hubbard winter squash, Blue Magic, and a Long Island cheese winter squash, which is related to a butternut squash. Here's the field diagram. The main plots were the tillage treatments, and they were 20 feet by 50 feet. The crop rows were 5 feet apart. In each tillage treatment were subplots of the three varieties, 1 row per variety. The plants were 4 feet apart with 12 plants in the row. That gave us a population of about 2,178 plants per acre. In between the tillage treatments, we had guard rows of pie pumpkins, and in the diagram that would be represented by the solid lines between the tillage treatments. Half of the experiment, or two replications of each tillage treatment, was direct seeded here, and half was transplanted there. Our soil is a Tracy sandy loam. The fall 2019 soil test indicated no need for phosphorus or potassium, and so the only major nutrient we applied was nitrogen. This is the timeline for the season. After tillage in April, nitrogen at about 50 pounds an acre was applied from urea in mid-May, and then followed by additional tillage in the bare plots. We started transplants at the end of May in the greenhouse, had to reseed the Bayhorse Gold due to some germination trouble, and then we direct seeded in the field the second week of June, rolled and crimped the rye, transplanted a few days later. We irrigated a number of times during the season. Side dress nitrogen at 60 pounds nitrogen per acre from UAN in late June, and then harvested September 12th and 13th. We grow the transplants in a small poly-covered greenhouse, harden them outside for a few days before transplanting, typical of transplant production. Our biggest weather challenge was the dry early season. The large graph here shows rainfall in the dark blue bars, potential evapotranspiration in the yellow bars, and irrigation in the light blue squiggly bars. From the end of May until mid-June, there was no rain, and that was about during the period that we planted. We probably should have irrigated sooner than June 16th. We had several periods of rain in July, and that proved excellent for weed growth, as you'll see, and then it was dry again in August. The small graph here shows the cumulative rainfall over the season and the cumulative estimated water balance for the pumpkin crop. The temperature was a little bit above normal. You can see the growing degree day departure from normal was positive for June and July during most of the growing season for the crop. The pesticide applications are listed here. I'll talk more about weed control later, but I want to mention the insecticide application in July. We held off on applying insecticides early so we could observe any possible treatment effects, but at that time we did apply for squash bugs. We applied fungicide twice for powdery mildew and once to protect against downy mildew. Let's take a look at what we saw through the season. These photos from April show where the direct seeded plots will be. The plots start at the orange flags and go back about 50 feet, so something like that. And these are plots just before we had applied any treatment to them, so it's just showing you what the field looked like at that time. This is at the end of May, about a week after the glyphosate treatment. You can see the rye is dying there. The plots with the standing rye will be rolled after direct seeding or just before transplanting. And then the tilled plots, these are the conventional or the bare treatment. Mare's tail is a plot problem weed for us and was throughout the season, and at this point mare's tail is a few inches tall in the standing rye. On June 9th, we seeded with a John Deere MaxiMerge planter. We dropped the seeds in the planting tubes by hand. And this is what the plots looked like just after seeding and before the rye was rolled. That roller crimper came on just after seeding, and the photo on the left was in some neighboring plots with sweet corn that we planted the same day. That tool worked quite well and crimped the rye to kill it. The photo on the lower right shows the pumpkin and squash trial after rolling. I think we'll have a little video of the roller going there. A few days later, we transplanted by hand in the bare, the herb, and the rolled rye plots. And I want to mention that although we transplanted by hand, as you can see on the left here, it is possible to do mechanically. In the past, we've used this no-till mechanical transplanter to transplant after no-till transplant after wheat harvest, and it's worked well. And there are growers who use planters similar to that to plant into rye. Of course, in the bare ground plots, a water wheel transplanter would work just fine. Our main challenges in stand establishment were seed predation and soil moisture. In the no-till treatments, particularly the standing rye or the rolled treatments, we had trouble getting the seed buried and well covered. We had trouble getting a good furrow, and a lot of seeds were eaten most likely by 13-line ground squirrels. As I mentioned, it was dry, and probably especially so in those rolled rye plots where the rye was still taking soil moisture up until when we planted. We did irrigate about a week after seeding, but earlier probably would have helped. There were a lot of armyworms in the rye plots, but they did not seem to bother the seedlings. Because we intentionally overseeded, we planted more seeds than the final stand we wanted, we were still able to achieve the desired population by thinning after a few weeks, although the plants were not evenly spaced along the row. By 11 days after seeding, there was some emergence in all of the plots, but the bare plots were ahead. We counted emergence, and in the next slide I'll show graphs of what we found. The first graph in the top row shows results just a week after seeding. The bare plots, which are the light gray, had more than 50% emergence. The herb glyphosate treated plots had less than 5%, and the rolled plots even less. So seeds in the conventional tillage plots emerged more quickly than in the herbicide killed plots, and those emerged more quickly than in the rolled plots. By the last counting date, 23 days after seeding, there was no significant difference in the total number that had emerged, although there was a trend that followed the speed of emergence. The lower graphs show the difference among the different crops. The Bay Horse Gold, the pumpkin, emerged a little quicker than the Blue Magic Hubbard squash, and that emerged a little quicker than the Long Island cheese. And by the last counting date, the pumpkin had higher emergence than the other two. These are the transplanted plots on June 20th. The dry weather did lead to some wilting after transplanting, and we observed some marginal scorch. We had fairly good survival among all the plants, and we replanted the few that died. By 2.5 weeks after direct seeding, we can see the rows easily in the bare ground plots, not quite so easily in the herb or the roll plots. The weed issues that will be present all season are clear. In the herb plots, there was not only the mare's tail, but nightshade is a few inches tall and is well established, and there's mare's tail still alive in the rolled plots. At this point, the transplants are pretty much established. In the bare plots, lamb's quarters, pigweed, and nightshade are just emerging, but it's clear that there are some places where pre-plant tillage didn't entirely kill all the weeds in those bare ground plots. I want to mention the in-season weed management program. We had a pre-emergence herbicide strategy. That's a mix of clomazone and ethylfluralin, and we tank mixed it with a little bit of Curbit, which is ethylfluralin alone. This was broadcast right after seeding or applied only between the rows just before transplanting. It was applied to all of the tillage treatments. This is a sprayer that we use, and for the transplanted plots where we apply before transplanting, the nozzle right over the row is turned off so we don't apply where we're going to be transplanting. We had a post-emergence application of Sandia to control pigweeds and to provide some residual control of broadleaves. It was broadcast to the bare and the herb plots because the roll plots had very few susceptible broadleaves at that time. So that was at the end of June, and at that time we also applied a grass herbicide, clethodim, to all of the tillage treatments. The photo on the right here gives you an idea of how that pre-emergence herbicide worked. The band where the weeds is a place of, for some reason, the herbicide didn't get applied there. And to the right where there's no weeds, that's the activity of that strategy and Curbit. The bottom photo here, you see the Sandia working on a pigweed, having no effect on the eastern black nightshade. As I mentioned, we had a big problem with mare's tail. We had problems with nightshade, and so we spent quite a bit of time hand weeding those. In one plot, pigweed was not controlled by the Sandia, and we spent time hand weeding that. Of course, in a farm field, all that hand weeding wouldn't be practical. On July 2nd, we took the final emergence count in the direct seeded plots and thinned to the desired stand. As we look at photos for the rest of the season, you may be able to pick out when the plots have been weeded or parts of the plots have been weeded. By July 9th, the largest plants are just about ready to vine, and then there's a close-up of individual plants of the different types. The flowers are just starting to bloom in Blue Magic. At that time, the transplanted plots are still a little bit larger. And in these plots, you can clearly see the strip where the herbicide sprayer was turned off at the pre-emergence herbicide. You see that strip of weeds right over the row. And then the individual plants. Differences in the plant size and the tillage treatments are quite apparent here, and we saw that from the beginning, and you'll continue to see it as we look at more photos. This graph just summarizes the estimate of vine diameter or length that we estimated on July 9th. And in these graphs, the pink bars are the bare plots, the green are the herb plots, and the blue are the roll plots. And generally, the bare plots were the largest, followed by the herb, followed by the roll plots. The three panels are the different varieties: the pumpkin, the blue Hubbard squash, and the Long Island cheese. And then the top grafts are direct seeded, and the bottom grafts here are the transplants. We also took some detailed insect counts on July 9th, and this slide shows the main insects that we saw. Squash vine borer moths were laying eggs by July 2nd. You might be able to see the moth here on one of these direct seeded plants that we were thinning out. We did lose some plants to the larva later in the season. And at harvest, there were 1 or 2 pumpkins that had a larva in the pumpkin. Here's the hole, and we dug in there and found a larva that would have been from a second generation of that squash vine borer. We saw squash bug adults early in the season and frequently saw egg masses. Our July 17th insecticide application seemed to keep the nymphs under control until quite late in the season. We did see both striped cucumber beetle and western corn rootworm beetles. The populations weren't high early in the season when the plants were really small and when the threshold for treatment is low, so we didn't treat for those. They were numerous in flowers once they opened and seemed to really like the blue magic squash. When we took counts on July 9th, we did see some differences in the tillage treatments, and the first set of graphs on the left here shows the different tillage treatments. The top graph is the counts of squash, number of plants with squash bug egg masses, or the percentage of plants with squash bug egg masses. And in the herb treatment, which is the green, there were a higher percentage of plants had at least 1 egg mass than in the bare or the rolled rye plots. The second set of graphs here show the different varieties. And it appears that the squash bug eggs were more prevalent on the jack-o'-lantern pumpkins, and the western corn rootworms and the striped cucumber beetles were more prevalent on the blue magic squash than on the pumpkins or the Long Island cheese. Remember that at this time when we took this count, the plants were also different sizes, and that can also influence insect preference. We had hail in early July, and there was some damage to the leaves, the stems, and the young fruit. By mid-July, the vines were spreading. Hand weeding is ongoing. The middle photo here is a before and the top and after photo of a plot where nightshade was removed. This is the transplanted plots at that time. And by the end of July, we have a solid cover in the bare plots, except where there's a gap in plant spacing. The gaps, whether they're due to uneven emergence or later plant death, allowed weeds to grow with less competition from the crop. And as the season progresses, you'll really be able to see the resulting annual weed growth in those areas. Transplanted plots were similar at this point. And by this time, we had fruit development in all of the plots. The Long Island cheese was the latest to set fruit, and the Blue Magic, the Blue Hubbard, was the earliest. Here you see a fruit where you can actually see some of the hail damage onto the fruit on an early set fruit. As we go through the month of August, the vines, of course, continue to grow. We get more fruit set, and of course, the weeds continue to grow as well. These are the transplanted plots at that time. And here I want to mention that the plots begin at these white foot labels. So the weeds in the front here are weeds that are in the alley between plots. Here's transplanted pumpkins at that time. And direct seeded pumpkins on August 20th. Transplanted. And then September 4th, just about a week before harvest. And the transplanted pumpkins and squash. And these views down individual rows are just before harvest. The top photos are all the pumpkin, the Bay Horse Gold pumpkin, and then in the middle the Blue Magic squash, and in the bottom the Long Island cheese. As mentioned before, the large weeds like we see here are often associated with gaps in the crop stand, and we saw more of that for Blue Magic and Long Island cheese. Here's a similar photo in the transplanted plots with the Bay Horse Gold on top, Blue Magic Hubbard squash, and then the Long Island cheese pumpkin on the bottom. By this point, the vines were growing all over the plots, so these pumpkins that you see here were coming from another row, not from the Long Island cheese row. We harvested, like I said, in mid-September, put the fruit from each row at the end of the plot, just so you can get an idea of the relative numbers and size. This is the harvest from the direct seeded plots. And here are the transplanted plots. We counted, weighed the fruit from each plot, and calculated the average weight per fruit. So in the next few slides, we'll present that data. In the direct seeded plots, the tillage treatment didn't significantly affect the fruit number, or the total fruit weight, or the average weight per fruit. The values in the table here are per plot. If we convert to per acre, the overall average was about 2,650 fruit and 13.5 tons per acre. The individual crops did yield differently. They all produced about the same number of fruit per plot, but the pumpkin Bay Horse Gold had the highest yield of 265 pounds per plot, or about 24 tons per acre, and the largest fruit, almost 17 pounds. Blue Magic had the smallest yield at 69 pounds per plot, and the smallest fruit, about 5¼ pounds, and then Long Island cheese was intermediate, 112 pounds per plot, and about 7 2/3 pounds per squash. In the transplanted plots, the tillage did make a difference in fruit number and yield per plots. And in this case, the bare plots had the highest yield, 22 fruit and 207 pounds, or almost 4,000 fruit and 19 tons per acre. The herb treatments produced only 64% of the number and 75% of the weight of the bare plots. And the roll treatments were intermediate. They produced 73% of the number and 84% of the weight of the bare plots. The average fruit size was similar in all those tillage treatments. In the transplanted plots, the cultivar affected the marketable weight and the average weight per fruit. And similar to the direct seeded plots, Bay Horse Gold pumpkin had the largest fruit and the highest yield of 27 tons per acre. Blue Magic had the smallest fruit and yield of about 6.8 tons per acre, and the Long Island cheese was intermediate. In the transplanted plots, the tillage treatment had slightly different effects on the average fruit weight depending on the cultivar. So for the pumpkins, it made the smallest fruit in the bare plots. The Blue Magic squash made the smallest fruit in the rolled plots and the largest in the bare plots. And the Long Island cheese squash made similar sized fruit in all the plots. I wanted to mention some of the disease problems that we saw during the season. We saw a yellowing vine. It's possible that this was the yellow vine disease that's transmitted by squash bugs, but we did not confirm that, and we saw it just in one of the pumpkin plots. We saw several cases of fruit rot and diagnosed fusarium fruit rot. At that time, there was also bacterial soft rot. Powdery mildew did come in during the season, but the two fungicide applications seemed to keep it in check. The Blue Magic squash was prone to edema, And most cases were not this bad, but a couple of fruit were so severely affected that they may not have been marketable. Another thing we noticed was that in the rolled rye plots, some of the rye had matured after rolling, and seeds matured seed, and that seed sprouted. So here on August 20th, we're seeing young rye plants coming up, and we could see that they were coming. They were growing right out of the heads of the rye that had been rolled. In another area on September 4th here, there's an area that was rolled a little bit later, and it has an even thicker stand of rye. I checked the plots in November, and this is what they looked like. After harvest, the plots were mowed off, and in the rolled plots, you could see a little bit of rye coming up there. And then in the transplanted plot, similar thing, you can see some rye regrowth in the transplanted plots. That was interesting to me. I know there's concern that if rye had sprouted earlier in the season, it could become a weed problem in the pumpkins. In this case, it didn't sprout early enough to be a weed problem, and if one wanted a cover crop after the pumpkin crop, that self-sprouting rye would be a simple way to get it, it seems to me. So we plan to continue working in this system. Our main challenges are getting a consistent seed furrow depth and getting it closed well enough to improve emergence in direct seeding. We need timely irrigation around planting, and then definitely better weed management. When we have a system that works, we can then move on to do other work and learn more about how other practices are best used in a no-till system. Thanks for taking some time to join me in this look back at the season. If you have questions or comments, please don't hesitate to contact me at the email or phone number here.